Hi, some days ago I got from a customer a model with a drawing and with question how to model stairs with an arc. And this will be the content of this short video. My name is Ivan Beleš and I am support engineer at SCIA Data Service for SCIA Engineer and Idea Statica. Now we are in SCIA Engineer. And you see what I have to do. We have a part with a flat plate with an inclination, then one part with an arc but without inclination. This part will be horizontal. Then next part with a rounding and inclination, and also again horizontal part and part with inclination but simply a rectangle. The height is 3.6 meters. You have more possibilities how to model this structure. So the first one, which maybe all of you will prefer, is to draw everything directly in 3D. If you want to do it, you need the points. You have to click on the points. So we need the 3D points. You can prepare it, for example, with lines. So I will draw the lines from, for example, from this point. So you have to be exactly, you see the drawing is not very exact. In this length, space 1.2 meter. If you are working with, here is it, with tracking guides, endpoints and midpoints, this is what we will need. So this is 1.2 meter long. This will be also 1.2 meter. Then we need from this point 2.4. Again, space 2.4. Enter. Escape. And on the end we have 3.6. So again, the line from here, space 3.6, enter, escape. I will check if it is correct. Okay, so this is the start. So I will copy it to all corners, which I will need later. So right mouse button, there is a function to copy. There is also here a function for copy. There is also here a copy function, and you can write it in the command line. So you have a lot of possibilities how to find the functions. So everybody prefer another way how you want to work. So this is finished. Now I will copy this one, but I have to zoom correctly. Oh, start point. This is so right mouse button, copy, start point. Start point is here. It's correct. Okay, this one. I have to zoom very deep because I'm not sure if the lines are connected. This is sometimes problem if you get drawings from outside of your company. You know that sometimes you have more work with correcting of this drawing than with the drawing itself. So copy, and so I have to go a little bit deeper. Then to this one. This one is correct, and move it here is also okay, and here, what do we have here, is also okay. Okay, I have also midpoint, so I will copy it also to this one and this one, because I have to draw an arc. So, and also I will need to copy this one from here to the midpoint, and I will need also a midpoint here, but this one is 1.2, this is 2.4 meters, so I need 1.8 meter. So I have to draw a new line from the midpoint. This is this one, 1.8, and I can copy it on the another side. Okay, Now I have all points to draw the structure. Is well prepared. You can also prepare it in some CAD software which you are using. I missed some points. If you don't want to see all these points, then you can change it to category, for example, to basic input. No, here workstation structure. So we don't need something else. We need only the structure. That's enough for us. Okay, there is one icon on the bottom. And now I can draw. I start with the most difficult thing, with an arcs and with inclination. And before I do it, I will explain how SCIA Engineer works with shells. For shells, you need 4 lines. It works also with 3 lines, but you need, let's say, 4 logical lines. And each line can be, for example, a straight line, some polygon, some arc, spline, and so on. So 4 lines, I would say, I have taught. So first, so this is the ground zero, and for example, I move this corner to the top. So we will add. We have 4 lines. This one, this one, this one, and this one. Line number 1, 2, 3, and 4. What is SCIA Engineer doing? SCIA Engineer transforms the line 1 to line 3 and vice versa. And also it transforms 2 on 4. So because we have only straight lines, we still get after this transformation straight lines. So it's very simple. This is our model, what we will get. If you have one of them, for example, an arc, the first one is straight line. Third one, fourth one also 1, 3, 4, but the second one is an arc. So 1 will remain straight line. It's going over this arc to the top and back to the bottom. But from 4, from the straight line, we will slowly get a rounding with an arc. So, and so on. For example, if you have 4 arcs, then arc will be transformed to again to arc, so you get since such nice Greek chapel. So that's the explanation. So we need 4 lines. I select shell. It doesn't matter these properties. It's predefined. I only change the. It's okay. I don't see. Okay. So what I need, I have to draw it over this point. So the first point, second point is connected with straight line. Then arc over this point to this one. Then I am again back automatically in straight line, so you don't need to change it. Only change it if you need something else than straight line. And go to this point. And that's all. This one is done. This and all other parts are simple flat plates. So all parts you can draw with plates. So first point, second one, arc, here, straight line, and arc to this point. I have to look on it if it is correctly connected. Yes, we will see also on the points. Very good possibility how to check if you have connected the nodes before you start this check structural data and so on. These automatic functions simply activate the node numbers, and then if you see that you have 2 numbers written one over the another, you know that there is something wrong. So then you can move the nodes, or you can start this check check structure, and these nodes will be then joined together. So, and finish this part. So this is one flat rectangular plate. This is one plate with arcs over this point here, straight line and arc. Then I will show also another possibility how you can do it. And the last one is a plate. It doesn't matter where you start, and it doesn't matter which direction you draw. The start point have one important property or function. There is also the start point of the coordinates. And also if you then input, for example, hinges on the lines and not on the full line, then you have to select the start and end point. If you say, for example, half meter from start, 1 meter from end, and only on a part of this line you want to input, for example, a load or a hinge, then you have to know in which direction is this structure drawn. So, and that's all. This is drawn. So we have also another possibility. I will delete, or I can copy this plate. Copy from here, for example, blank 10 meter on a side, and delete it. So what you can do, you can also draw directly a shell, but on the 0 level in the XY plane. So you can draw a shell as before, but I will not, for example, I don't have these vertical lines. So I draw it only in this XY plane. So I start with an arc from, I have to zoom, from this point over the midpoint to this one. Then I am again in a straight line. You see, it was not really well drawn. So, and then go over an arc, this point to here, and close it. So now I have shell, but not on the right position. And so you can simply select the shell as first, move it, right mouse button, move it for example, from this point to this height. And now I can change simply the heights. I select the nodes and I can drag them. So it has to be for 0.6 meter higher. So I can simply move from this point blank 0.6. And you can move also these two nodes. Or you can simply drag and drop them. So you can simply take them and drag. So this is also possible. And the third possibility, I will delete it, is you draw a plate. It's also possible. You start with a plate, not with a 3D, but you have to think about it that this plate will be changed to a shell later. So I start with an arc from here over this point to here. Then I have a straight line to here, over an arc to this corner. Where is it? Here. And I close it. Okay. Now it's a flat plate. Standard flat. Shape is flat. But you can, first I move it on the right position. Right mouse button. Move from here to this position. And now you can select the nodes and simply drag them to this position, and SCIA Engineer automatically changes this plate to a shell, to a 3D shell. So I can simply move it. So you have more possibilities. You can decide how you want to do it. That's almost everything for the modeling, but it's not enough for calculation. I will run the calculation of or generation of the mesh. Okay. I have prepared before that I get for the mesh that I get the so I will delete this one that I get the mesh and also the coordinate systems. So but you can do it, view settings, can do it here. You can activate the mesh and local axis of mesh elements. You see, what do we have? That's okay. Okay. You see that the X is going in some direction. Here is going X in another direction. Here also in another direction. I want to have the X line over this middle line from bottom to top. Then I can later calculate, for example, reinforcement in this direction and in orthogonal direction, because in this picture everything would be in another direction, also the internal forces, so that's not good for us. So what you can do for this shell, you have, I think this possibility is the best, tilt vector normal to line. You can also work in shells with this smallest angle with vector, but this is a very good position. Then you have 2 points. The first one is this center point, and the second one is from this center point. I push the shift button, move to this node, release the shift button, go to the top, for example, to this position. So now I have a line, and I would say the y axis is going to these points. And this, I will do it also for this plate and this plate. The same. Select this node. You can draw these nodes before and to this one. So for this plate, we can simply rotate it with an angle. So this is X, should be go there, but this is okay, this X, but I will change this X. Should be rotated around 180 degrees. So you can do it also on this way. 180 degree. Okay. Now we can generate the mesh and check the axis. So X is every time going to the middle. So you can change it. This is not correct. You see, this one is not correct. I have to check it and do it again. Maybe it's better if you do it extra for each plate and not mix for more plates or more shells together. Here, okay, now it's correct, but I have to change it. I want to have the y axis is going to the center, and here also the this is already the y axis. We have to look on it if it is correct. This have to be changed to y, and this have to be rotated around 90 degree, but I think minus 90 degree. Okay, and this one have to be rotated only around 90 degree, I think. Yes, the y is then going to here. So let's generate the mesh and check if this one part is correct. Okay, x is going to the top. Everything is okay. So you can now, it's not necessary, but I do it to add some supports, some hinged support on the start line and on the end line. The self weight is already defined, so I can simply, here is it also, calculate the mesh. Okay, the precision is not okay, but I want to have a little bit bigger elements to see all these lines, all these local coordinate systems. And now you can go to results, for example, internal forces, and we want to see mx, which is going with the stairs. This is mx from self-weight. Table setup is not important for me. I want to see only the picture, and you see they are going from bottom to top. It's nice, smooth lines. So I hope this will help you with the modeling. Thank you very much for your time.